So our first topic is the number needed to treat, or NNT. What is NNT? NNT is the average number of patients who need to be treated to prevent one additional bad outcome. For example, 30 patients needed to use drug X to prevent lung cancer compared to a placebo drug. So in this example, you can see that a drug X needed to be used by 30 patients to prevent lung cancer compared to a placebo drug. So basically, here 30 is NNT of this drug X. So what is NNT? NNT is average number of patients who needed to be treated to prevent one additional bad outcome. So in this example, you can see that NNT is 30 because 30 patients needed to be treated with the drug X to prevent lung cancer. The other way of calculating NNT is NNT can also be defined as inverse of the absolute risk reduction. Just remember that NNT is either, there are two ways by which this question will be asked in the Plab. One is like this, that a straightforward question will be given to you and you will be asked to calculate NNT. And the second way is that you will be asked to calculate the NNT from absolute risk reduction. That is, NNT is also defined as inverse of the absolute risk reduction. We will do some examples in the coming slides as well. Now, there are some terms that you need to remember. The first of them is AR, that is absolute risk. What is absolute risk? The number of events so number of events divided by population is absolute risk. Absolute risk in the treatment group, and ARR is, or absolute risk reduction is, absolute risk of the control group minus absolute risk of the treatment group. And relative risk is absolute risk of the treatment group divided by absolute risk of the control group. So you need to memorize these formulas. Example 2. Now we have two groups. One is control group and the other is treatment group. The control group has a death in 20% of the patient and the treatment group has death in 10% of the patient. What is the absolute risk reduction?
So the absolute risk reduction is the treatment control group minus the treatment group.
Yes, absolute risk of control group minus absolute risk of treatment group. Just give me a minute. So ARR is absolute risk in the control group minus absolute risk in the treatment group. So the control group has death in 20% of the patient, and the treatment group has a death in 10% of the patient. So 10%, sorry, 20% minus 10% is 10%. So absolute risk reduction is 10%. Now, how many patients would you have to treat to prevent one death? Or in other words, they are asking about the NNT. So we discussed that NNT can be defined as inverse of ARR. So 1 over 10%. If we want to convert percentage into numbers, then we will need to divide it with 100. So 10% is basically 1 over 10 over 100, or 100 over 10. Tens are 100. So NNT is 10. Did you get this
Yes.
point? So the NNT here is
10. So what is the exact
10.
meaning of absolute risk reduction?
Absolute risk reduction means the reduction of the risk after treatment.
Right.
For example, if someone has an absolute risk of getting a cardiovascular disease is 10% without treatment,
Right.
then after treatment with a certain drug, let's suppose with the antiplatelets such as clopidogrel or aspirin, how much chances of his absolute risk is reduced. So this is
Right.
called absolute risk reduction. That's why we calculated absolute risk of the control minus absolute risk of the treatment or after the treatment.
So the controlled group is the one which is not being treated. Like
Yes, control group is without the treatment.
Right.
And treatment group is the group, and
So this,
we know that the purpose of, yes,
no, that's fine. Yeah.
the purpose of treatment is basically to reduce the absolute risk.
Okay. So the answer which comes out to be 10 at the end, will that be in a percentage or will it be a number?
In the Plab one, it can be asked both way. So it depends upon your options. If in the
Okay.
options they have given you the percentage, then you will calculate according to the percentage. And if
Right.
they have asked you the numbers, then you will need to give the numbers.
Right.
Whenever you can want to convert percentage into numbers, you will divide it with 100. And whenever you want to convert numbers into percentage, then you will multiply it with 100.
Right.
For example, if you want to convert 10 into percentage,
Yeah.
or 0.1 into percentage, then you will multiply it with 100.
Right.
And if you want to convert this percentage into numbers, then you will divide it with 100.
Right.
Next topic is standard deviation. Standard deviation is basically deviation from the central tendency, or deviation from the central value, or deviation from the average, you can say. So basically, standard deviation is used to measure the dispersion of a set of values or observations. You need to remember these three numbers. That one standard deviation means that 68.2% of the values are within the one standard deviation, and 95.4% of the values are within two standard deviation, and 99.7% of the values are in three standard deviation. So to measure the dispersion in a set of values or observations, we can use standard deviation or standard error of mean. So in the Plab one, they will sometime ask you that which one of the following is used to measure the dispersion of a set of values. And in the option mean, median, mode, and standard deviation will be given. And you will select standard deviation or standard error of mean. Any one of them will be given. And if they ask you how to measure the central tendency of a set of values, then your answer should be one of them, that is mean, median, and mode. We'll do examples of mean, median, and mode in the coming slides. For now, you need to remember that what is standard deviation, what it is used for. It is used for measuring the dispersion of a set of values. And what is 1 SD, 2 SD, and 3 standard deviation. Now, our next topic is the important one. That is how to calculate sensitivity and specificity. To calculate sensitivity and specificity, you need to remember this 2 by 2 table. What is 2 by 2 table? This is a 2 by 2 table. Here I'll write disease, and here no disease. Here positive test result, and here negative test result. So in the questions which will be asking you about sensitivity and specificity, two kind of tests will be mentioned. One will be a screening test, and one will be a confirmatory test or diagnostic test. Screening test will be the initial test, and to confirm that the person really has the disease, it will be confirmed on a diagnostic test. Let's do an example, and then you will know. So 200 patients are enrolled in a study to evaluate the accuracy of a new ELISA-based test for influenza. 100 of the patients were diagnosed with influenza by the reference standard culture of respiratory secretion. So as I told you that two types of tests will be mentioned in the clinical scenario. And in this scenario, you can see that we have 200 patients, who are enrolled in a study to evaluate the accuracy of a new ELISA-based test for influenza. So we have advised, we have made a screening test for influenza, that is ELISA-based test. So this test is the screening test. 100 of the patients were diagnosed with influenza by the reference standard culture of the respiratory secretion. And this ELISA is the screening test, and we are checking the accuracy of this ELISA test. And this culture of the respiratory secretions is the diagnostic test. So 100 of the patients were diagnosed with influenza by the reference of standard culture of respiratory secretion, and 80 of the patients with influenza had a positive ELISA based test. Now we can say that we have total 200 patients. Out of these 200 patients, 100 were diagnosed to have influenza. How they were diagnosed? They were diagnosed on culture of the respiratory secretions, and 100 does not have the disease. Now let's, out of these 100 patients, 80 of the patients with influenza had a positive ELISA based test. So out of these 100 of the patient, 80 had a positive ELISA test. So we'll write positive result in this column, in this box. These 80 are the patient who has the disease, and also their screening test is positive. So we can say that they are true positive. Out of these 80 positive ELISA test, and 20 has a negative ELISA test. These 80 are true positive because they have the disease and their test is ELISA test is positive or screening test is positive. And these 20, though they have the disease, because we are writing them in the disease.
False negative.
Yes, false negative. Because why we are calling them false negative? Because they have that disease, but their ELISA test or screening test is negative. They are false negative. So 80 of the patient with influenza had a positive ELISA based test, as did 5 of the patient without influenza. So these 100 patients, out of these 100, 5 had a positive ELISA result, or out of these 100, 5 has a positive screening test result, but they didn't have the disease. So positive and without the disease, we'll write them here, and they will be known as false positive.
Right.
Because their result is positive, their screening result have the.
But their screening test is
And
ELISA screening is done.
Yes. How do we know that they don't have the disease? We know that by 100 patient does not have the disease. Do not have the disease. But out of these 100, 5 still have, so
Right.
we'll write them the positive.
Right.
False positive because they don't have the disease, but their screening test is positive. And the remaining 95 we'll write here. So these 95, what we call these? They don't
True
have the
negative.
disease. Yes, they don't have the disease and their test is also negative. Screening test is also negative. So they are true negative. Now let's calculate sensitivity. Now we can say this is A, this is B, this is C, and this is D. Now what is sensitivity? Sensitivity is of it to identify those who are truly sick. S for sensitivity and S for sick. The ability of a test to identify those who are truly sick. So we need to take into account this disease column. Because sensitivity is the ability of a test, so we'll take into account this disease column. And sensitivity is calculated by true positive, because sensitivity is the ability of a test to identify those who are truly sick. So true positive divided by total. That is true positive TP plus false negative FN, or total number of the patient in the disease column. So true positive here is 80 and total is 80 plus 20 is 100, 80 over 100, 0.8. To convert it into percentages, we will multiply it with 100. So our answer will be 80%.
8%. 80%.
So the sensitivity of this ELISA test is 80%.
80%.
Because 80% of the time it will identify those who truly has the disease, and 20% of the time it will give a false negative result. So to calculate sensitivity, we need to take into account the disease column. That is true positive divided by total patient in the disease column. Now let's calculate specificity. Specificity is the ability of a test to identify those who are truly fit. Specificity, F for specificity and F for fit. The ability of a test to identify those who are truly fit. So like we did in this calculating sensitivity, for specificity, the rule will be the same. That is true negative or D divided by total in the no disease column. That is 95 plus 5 or 100. So 95 over 100 is almost 95%. The specificity here is 95%. It means 95% of the times this ELISA-based test will detect the patient who are truly fit.
So 95 by 100.
Now,
so what will be the calculation?
95 by 100 is 9.5. 95 over 100 is 9.5, and to convert this 9.5 into percentage, we multiply it with 100.
5.
So 95%. Is that right?
Yes. So that means 95% of the patients, they are true negative.
Yes. In other words, you can say that the test ability to identify those who are truly fit is 95%. 95% of the time, it will detect the truly fit patient.
Right.
So sensitivity is positive, negative, disease, no disease. A, B, C, D. But just remember this 2 by 2 table, and you will never get these type of questions wrong. So sensitivity was, in sensitivity, we need to take into account this disease column, that is A over A plus C. And specificity was B over B plus D. Is that right?
Yes.
Now positive predictive value and negative predictive value. So when we are talking about sensitivity and specificity, then we were taking into account disease and no disease column. Now we are talking about positive predictive value. What is positive predictive value? Positive predictive value is the percentage of the positive that are true positive. Predictive value. So we'll take into account this positive, this row into account. We need to take into account this positive row column, because A is true positive and B is false positive, and we are talking about positive predictive value. So now for positive predictive value, our formula should be positive predictive value. What is positive predictive value? The percentage of positive that are true positive. So A over A plus B. This over this total. True positive divided by total positive. Because we are calculating the percentage of the positive that are true positive. So we need to divide this true positive over the total positive patient. Is this point clear?
Yes.
Now negative predictive value. Negative predictive value is the
D
percentage
divided-
of the, yes, D divided by
C plus D.
C plus D. That's right. So this is how we can calculate sensitivity, specificity, positive predictive value, and negative predictive value from 2 by 2 table. One other calculation that can be done from a 2 by 2 table is accuracy of a test. Accuracy, how to calculate accuracy? Accuracy is true positive plus true negative divided by all the total patients, A plus B plus C plus D. So this is how we can calculate the accuracy of the screening test, that how accurate the screening test is. So that we can calculate this by true positive plus true negative divided by total number of patients. That is A plus B plus C plus D. So these 5 things we can calculate from 2 by 2 table very easily.
Oh, this accuracy of the test, can you please explain again?
Accuracy means how accurate a screening test is.
Right.
The accuracy can be calculated by dividing true positive plus true negative divided by divided over total number of the patients. That is A plus D, true positive plus true negative divided by A, B, C, and D.
Right.
So if they ask you to calculate the accuracy of the test, then you need to put this formula and calculate the accuracy of the test.
Okay.
Now, absolute risk. Another example to calculate absolute risk. Absolute risk is the number of events in a given population. And the formula for absolute risk is the number of events divided by the total number of people within that group, or total number of population within that group. For example, we have 200 patients, 100 of them died while on drug A, 20 of them died while on drug B. What is the absolute risk for the patient on drug B, and what is the absolute risk of the patient on drug A? So absolute risk is number of events divided by population.
So it could be anything like death or whether disease.
Yes, it could be anything like that.
Right.
Event can be an episode of an MI. It can be number of people who died. It can be anything. Number of people who had lung cancer in a specific population. So it can be anything. It can be any event. And to calculate the absolute risk, you need to divide this number of events over the total number of population. So in our example, we have 200 patients, 10 of them died while on drug A. So what is the absolute risk of the population who is on drug A? Total number of population is 200 and number of event is 10. 10 of them died out of 200. So this is absolute risk for drug A.
Yeah.
Now absolute risk for drug B is number of events in population who are taking drug B is 20. So absolute risk for population who is taking drug B is 20 over 100. Over 200 is 0.1, and to convert into 0.1 into percentage, we'll multiply it with 100. So the absolute risk for drug B is 10%, and similarly, the absolute risk for drug A is 10 divided by 200, that is 0.05, and to convert into percentage is 0.05 multiplied by 100 is 5%.
5%.
So this is how you can calculate. Now another example is a study on MI shows that 10 patients out of 100 died who did not get a treatment, and 10 out of 100 died who received proper treatment. What is the absolute risk for the patients who got proper treatment? So what will be the absolute risk
10
for the
divided.
patient who got proper? Yes, that's right. 10 over 100 because 10 is the number of events in the population who received proper treatment. So 10 over 100 is 0.1. And to convert 0.1 into percentage, we multiply it by 100.
It's 10%.
Now, case control versus two type of studies. There was a question about these studies in the previous Plab 1 exam that was conducted in February. So you need to know that how to differentiate between different type of studies. So studies can be divided into two categories: interventional studies and observational studies. What are interventional studies? Interventional studies are also called randomized controlled trial. And the other type of study is observational studies. Interventional studies is studies we only observe observe patients. And placebo